BJS Biotechnologies. We're the creators of the xxpress qPCR thermal cycler. In this video we're going to have a look at the differences between the standard heating block used in the conventional Peltier-based system and the xXplate that undergoes resistive heating in the xxpress machine. On the left we've got a standard heating block found in a Peltier-based system, and on the right we've got an xXplate which undergoes resistive heating in the xxpress machine. The first obvious difference is their size and weight. A Peltier block weighs between 1 and 3 kilograms, whilst the xXplate weighs in at just 11 grams. This gives an indication of their relative thermal masses and the amount of energy consumed during the heating and cooling cycles. Let's take a look at each technology in turn. First of all, let's take a look at the standard heating block. It's the thermal mass of this heating block that constrains the thermal ramp rates that your machine can achieve. Most Peltier-based systems can reach a maximum of 3 to 4 degrees per second. This diagram shows a cross-section through a Peltier block. The PCR reaction mixture sits in a microtiter plate. These wells have a thickness of 200 microns. The microtiter plate sits inside a metal block, typically made of silver in expensive systems or aluminium in low-cost systems. This metal is then heated and cooled by Peltier blocks mounted on its base. Temperature measurements are made by a probe mounted in the base of the block. The main disadvantage of the Peltier-based system is the lack of accuracy during temperature measurements and adjustments. It's the temperature of the block that's being measured, a long distance from your reaction mixture. Now let's take a look at the xXplates. These have a very low thermal mass, enabling ramp rates of up to 10 degrees per second to be achieved during heating and 8 degrees per second during cooling. This low thermal mass has the additional advantage of preventing undershoots and overshoots of your temperature, meaning you can be sure that each reaction step has fully completed. This diagram shows a cross-section through an xXplate. The PCR reaction mixture sits in the plate wells on top of a layer of polypropylene, which is just 10 microns thick. Below this layer of polypropylene is the lightweight aluminium base, meaning there's very little distance for the heat to travel in order to reach the reaction mixture. The technology behind resistive heating is simple and relies on the xXplate being the highest point of resistance within the circuit. When a current is applied, the temperature rises. Cooling is achieved by passing pressurized air across the base of the xXplate. The diagram on the left shows the path of the current, and the diagram on the right shows the resulting increase of temperature using a thermal camera. The xXplate has a unique design. There are 6 points of electrical contact shown in the diagram on the left, and the current's able to pass through any combination of these 6 points, enabling us to direct the current and therefore direct the heat. This results in excellent thermal uniformity of plus or minus 0.3 degrees. There are 9 infrared sensors that sit beneath the reaction zone, and these are connected via an innovative feedback loop to the thermal algorithm. They take measurements 100 times a second and react on these measurements to adjust the temperature 25 times a second. So what do these differences mean to your work? You'll achieve greater thermal uniformity with our xxpress machine, which can lead to a greater improvement in the accuracy of your results. Also, with our faster ramp rates, you can achieve a 40-cycle PCR in just 10 minutes. Our xXplates come in 3 sizes. We've got a 24 well, a 54 well and a 96 well, all of which use lower volumes. This can lead to up to 90% savings in your running costs. For more information, please visit www.xxpressPCR.com.